All right, getting started, hopefully on time. Got a bunch of things I want to do today. Let's see here. I'm going to get everything organized and then we will get started very shortly. All right, so the only other thing I want to do is getting this running. There's our little guy. Let me get some music going on my end and then we're going to get started. All right, so yesterday I was doing a little bit of research, and what I came up with, where's our history 2D physics, platform physics 101. There was why don't I have proof of concept, physics worksheet, guide to implementing 2 for platformers. All right, I'll find it for my Twitter account. Twitter. I had tweeted this article yesterday from Gregman, and there's some really good stuff in here. It's all about sort of how they built this game for the Nintendo, and what I want to do is we're going to basically take a look at how they implemented physics, and my goal for today is to implement physics. Where is Pomo to do? And why didn't that load up? Interesting. All right, so my goal for today is to implement physics, sort of how this old Nintendo game did, MC Kids, and take a look at how we can get a very basic sort of shell of a physics engine working in this. I was playing around with some stuff where it is an endless runner, that's fine, but what I'm trying to do is get it to get this thing to be a little bit more, a little bit cooler. I did get some basic jump in, but there was some interesting stuff that this article had said about how it handled floating points and stuff that you really couldn't do on the Nintendo, and we're gonna basically deconstruct this and get this working. So my goal for today is to get the physics engine working. There's a lot of little extra details that I need to work out, but for the most part, this shouldn't be too hard. Really, what I need to come back and do is there's a bunch of different points that I need to test for on collision. And we're going to turn these points on and off based on what's actually going to player. So I was sort of getting there. I think what we need to start with is let's go in and take a look at our entity here real quick. And what we're going to do is create. We're going to. I missed it. What's your Twitter name? Oh, it's Jesse Freeman, JESSE FREEMAN, just like my Twitch channel. But this is programming MC Kids, and this is actually a brilliant tutorial. Not even tutorial. It's sort of like a case study almost of how they built this game for the Nintendo. And it's cool because there's a lot of things that I'm doing sort of very similar, so I'm not very far off. Yeah, it's a very easy Twitter name to catch. So what we're going to do is we're going to set up basically all these points just like they did, and I'm pretty sure this won't be too difficult to do. So let's do this. First off, what I'm going to do is I'm going to get rid of. I added some code in here to help me debug the physics, and what we're going to do is, whoops, I got rid of the wrong one. We're going to hide the grid position, And we're just going to focus on these green points and get these green points equal to what they should be for the player. Now, there's one other thing I'm going to do here. Configure collision 1420. Let me make this 21. And whoops, 19. All right, let's open up Photoshop. We're gonna start with the collision area, and what we want to do is I added some over the weekend I wrote the collision logic, and what we want to make sure now is that the where's Sandbox? What I want to do is let's open up the PSD here real quick. I also got some new fonts from Andrew, who did the artwork. He's going through and he's fixing all of the crap that I broke from his designs. But I just wanted to see some of this font is already loading in. I'll have to take a look at that later. I'm going to delete some of the old font and we'll use his font too. But all right, so here's what we want to do. Let's just take this guy standing, and in fact, what I'm going to do is let's set up the basic animation is just going to be player idle 1 and 2. Is there one with a gun? Yeah, there should be like an idle one with a gun. We'll look into some other ways of cleaning this up, but we'll do idle gun. All right, so if we reload this, what we're going to get is just his idle animation. Why does he look so stupid? I wish Andrew would be on the stream. Is that really all that? All right, I'm going to have him like fix that idle animation. We're going back to the run animation. I rather him look like he's running in place and not doing anything than all right, my dog's going nuts. Go get him. Go get him, Cujo. I have this little like stupid dog. And it barks a lot. It sits at the window and it waits for people to go by so it can bark at them. All right, so here's what we're going to do. I want to fix the collision area, and we'll basically set this to, where is our guy? Let's just pull out this animation. Like the body's centered, so I'm not terribly worried about. I'm going to mock up what I want this to be like. Yeah, it's sort of like that, but that like looks like a lab, which is... I'm not a big fan of labs either, but we used to have a pit bull, which was cool. And she was super sweet, but it was like nice to have like a dog that like, you know, I could put in a muscle shirt. All right, so what we're going to do here is I'm going to set up where I want these collision boxes to be. And we're going to basically configure it sort of like how it is in this right here. Right? His head, actually, he's got pretty big hair, but it was in the 90s, so we're not going to fault him for it. So we'll do something like this. Oops. We'll do here, here, and here. All right, so what we're going to do is we're going to create a system that's automatically going to sort of figure out where these things need to go. And this means that our collision area is really going to be 9 by 20. So let's do this. I'm going to set this to idle. I'm just going to set it to idle so we can match everything up. And then once we get this going, we'll clean it all up and we'll go to the other animations and stuff, right? So what we're looking for is. Used to have a Whippet. He only barked like 5 or 6 times total in 11 years. Super quiet dogs. I used to have a Keeshon. That was like my first dog. And Keeshons are awesome. They're like, I don't even know how to spell it. Keeshon. This thing was awesome because it was like a mix between like a lion and a dog. And it was awesome. I loved it, but it hated everyone but me. It also barked a lot, but I didn't mind it because it had like a good bark, and it just looked badass. I wasn't really a big fan of pit bulls, but until I met my wife, and she had one, and it was cool. But we used to live in the East Village, and like all the like drug dealers and crackheads on the street over by the projects, I'd be like walking the dog, and they're like, "Oh, we love that red nose. That's a good red nose. You fight that dog?" And I'm like, "Yeah, nah, man, I don't fight that dog." Like the ears aren't even clipped or the tail isn't clipped. But that's what happens when you live like a block away from the projects. Now we live in Long Island, so I have a little yappy dog. I forget what it's called. It's like a Lhasa Apso poodle mix. It's like tiny and annoying. Anyways, as much as you'd love to hear about my fascination with dogs, we're here to build games. All right, so we're going to set this to 11 by 20 for our collision. One thing I noticed that's probably going to be a problem here is, how did they set this up? How many? 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yeah. There's some middle ones here I'm missing. Let's get that in here. So we need it. We're going to need it probably here and here as well. Right? That's sort of what I was messing up was I had set up, if we look here at tiled, I had set up this sort of, you can't see it in the map, but it's there. I should probably just make a quick tile for it. Where's sprites? I don't know. We'll just use this. Wait, that's not going to work. That's going to be, I don't know. Do I have like a solid edge or something? Sure, whatever. We'll just use this. Whoops, crap. I don't want to do that on the wrong layer. All right, so basically we'll put that there. I'm going to save the tile map and reload this. And so what you see is like he walks right past that, but he stops there. So I did get basic collision going, but what it was I wasn't really sure about the that's sort of weird when it like you see it move forward, but it doesn't move the player because it does the test and then it goes back. So I'm close. I just was missing this. This was the missing piece. So let's go ahead and we're gonna we'll figure out this logic. Because what I'd love to do is add in a whole bunch of other really cool stuff. Oh, you know what I never did? I wonder, well, not that I never, oh my God, I'm starting to talk like my 8-year-old. He drives me nuts when he says, I never did this. And it's like, yes, you have. Stop using the word never. I was wondering if people were still rating my game. My game on Lunadaria is like super broken. Weird having the A button to start instead of one of the other ones you use to play the game. Unfortunately, neither of the main things, jumping or shooting, felt good or satisfying. The shooting, SFX sounds really dull too. Respawning over pits isn't great either. Very keen to try out the engine at some point, though. Hope you fix it up. Yeah, my Lunadaria game was a hot mess, which is sort of why I'm rebuilding it now. I was hoping to get it fixed in time. If I get the physics engine working on my flight tomorrow, I could probably fix the rest of it and then re-push it up to Lunadaria. But yeah, none of it feels really good. It's broken. That's I mean, I've not completed Lunadaria before, but it sucks to like complete Lunadaria and then not have it working. So all right, here's what I'm thinking. This is our update physics. I'm kind of thinking of just ignoring, well, let's do this. We're going to go through and we're going to calculate all of the points that we need to for this. So we're going to do local collision points, right? And we're going to create this as a table. And then we're gonna just go through and we're going to start with the first point, and then we're going to work our way through the sprite in order to figure out where it needs to go. And then what we'll do is based on we'll give them names. We're going to do some stuff just to sort this out. But what we'll start with is let's go into Photoshop, and I got to fix the collision area. So we're going to start where the collision cylinder or box is going to be 11 by 20 for this particular character. So let's see here, 11 by 20. So let's set this to 11 by 20. And we got to fix this collision stuff first. So here's what 11 by 20 looks like. Now, what we want to do is we're going to create an offset of 7 by 4. And this is where I wasn't very happy with the, I was getting sort of confused. Now watch, 7 by 4 is going to move the cylinder up. And what I'm going to do is we're going to go into the code collision and we're going to change we're going to change this value. Now, when we go to debug the collision, what I want to do is this. Here's our temp rect. We need to, first off, we want to use the temp rect as the position. So let's get rid of this. And the goal, what I sort of screwed up is I just copied this code out, and it occurred to me yesterday is that we should only be drawing the temp rect, which is the rectangle that we use to find the bounding area of the collision. So what we're going to do is when we call, we're going to change this so it collides with entity, test collision, debug, and we're going to pass this all the way through. And debug, and what we're going to do here is if debug equals true, well, we don't need that. We can just do if debug, then n temp rect. And now on our player, let's just go here to update, and we'll get rid of debug collision. But what we should do is call test collision we'll pass in the entity. The collision type is enemies, and we'll set this to true. All this is going to do is we're always going to test. We're always going to test for a collision on any of the enemies, right? This should actually be test collisions. Let's just fix this. There we go. So now if I rerun this, it should draw the box, which it didn't. I set this to true. Enemies true. Collides type debug. Collides with enemy. Target A, target B, collision type debug. Collision type equals collision type. I see. Now it's only doing it if let's do it out here, where we'll just copy over the collision information, try to do debug on it, and now it'll do it or not. What the fuck? What? Okay. That's annoying. You know what? I see why I was doing this manually. I'm going to revert this, because I don't want to spend too much time on... Well, okay. I have to fix this, so let's get this to... We'll have to do a different way of cleaning this up. basically what we should do is create a function, and we're going to do function calculate rect. And there we'll keep the temp rect, and all we're going to do is return temp rect. All right, so we're going to calculate the temp rect here. Calculate rect, and what we're going to do is we're going to pass in the entity here, which will update the hit rect. We'll get the scroll position, blah, blah, blah. All this should work. And what I want to do is, the reason I'm pulling this out is I got to get this to be consistent. So when we come down here and we calculate this rect, we need to do this on, oh, I see what I'm doing. Whatever entity we pass in needs to use this rect correctly. So we were doing this on target B. So this would be target B. Let's see if this works, just out of shits and giggles. There we go. Okay, now we're back. All right, the reason I'm doing this is because now we have broken out this, and we want to make sure this is always consistent, right? So whatever entity we pass in, we'll consistently be doing it. And what I wanted to do is add plus here, and there we go. Now the rect is correct. We'll have to go back through everything and sort of fix that. So what I was thinking was, all right, let's see if we can now what we want to do is go through, and the math isn't going to be very complicated to do this. Let's go into our physics and let's create all of the collision points that we need. So in order to do this, we're going to need to we're going to take the entity's hit rect. So let's go here, and my monitor feels like it's going to turn itself off. So apparently it doesn't realize that I'm using it. All right, so collision points, what we're going to do is we'll do left, top, actually we'll do top, TL, T, top right equals new vector 0, 0. Then middle left equals a new vector. I got to fix this typo here. 0, 0. Right, middle right equals. Oh, why am I copied the wrong one. 0, 0. Then there's bottom left equals new vector 0, 0. Bottom and bottom right. All right, so these are all of the collision areas that we need to test. And what I wanted to do with this is if debug equals true. If debug equals true, which we don't need that. If debug is true, then what we're going to do is we're going to go for I total collision points. And then we're just going to call, let's see here, debug physics. And we'll pass in that test position. We'll go to collision points, I. And that's not doing anything, huh? Oh, because it's not going to be... it's probably putting it like off the screen where you can't see it because it's all set to like 0, 0. So let's figure out how to calculate the first position. And what we're going to do is... so we're going to create a new top left equals new vector. And this is going to be the top left position is going to be entity rect x. Actually, let's just do it this way. Oops. Entity rect x entity rect y. Let me get rid of debugging these other points real quick so that we can... Because now it's not drawing anything and it's driving me nuts. Why is it not drawing entity? Oh, it should be hit rect. Well, it should be entity rect x plus hit rect x y. All right, so why is this not debugging correctly? Update any physics true. We get to debug I. Ah, right, because it's not an array. We have to manually go through each one of these. All right, we'll do this. We'll do this manually, and then we'll start one by one. And so what we're looking for here is top left. $46. Come on. Entity hit rect x. There we go. My brain's not working that well today. All right, so there we go. We have 1 point in the left position, and we're only going to start. So there was some interesting things that they. So one thing that they were doing, which I haven't decided yet if I want to do. Well, I guess we should. Well, no, okay. Basically, we only need one set of points because we can calculate the other set of points by flipping the player. So let's do this. Let's just get one set of points. It should be... Well, all right. we'll do all these by hand, and then we'll figure out which ones we need to do and how we can flip it. Because then we need to figure out the top. And what I'm actually thinking of is this should just be an array like this. And then we'll do something like this. Because I want to reference each one of these. Because the next one, which would be top, is going to use the X value plus the Y value of the previous point. This is our main point here. And then what we're going to do is we're going to add the entity hit rect dot width multiplied by divided by 2, and we'll do math dot floor. And we're going to subtract 1. And go through another error. Oh, this should be T. And let's just make sure that this works. Collision points TLX entity hit rect width. And get rid of this. And this, we don't need that. So now we just need to debug. This actually will work out better because we only want to debug these when we actually need to use them. Top. All right, so there's our top position. Then our next position is going to be this plus, whoops, wrong one. What am I doing here? This is T right. Hold on, I just want to mark off this Pomodoro. So we're doing physics. All day, every day. All right, so now the next one's going to be the top right. And all we do is we take the top left point and we add the width of the hit rect to that position. And we leave this as is. And now we just need to debug it, which I keep forgetting to do because we're doing it manually. Top right. All right, there we go. And what we want to do is subtract this by 1. And that'll give us our, whoops, wrong place, width minus 1. All right, so that'll give us our next collision point. And then next up, I'm actually going to move this down here. And what I want to do is we're going to sort of do these in a little bit of a different order. Let's do bottom, which is just going to be we'll do middle left, which is just going to be we're going to take the top left. All right, so we're going to use the collision point top left X value, leave it the same. In order to get the middle, then what we need to do is we'll use the Y position, math.floor, entity hit rect height divided by 2. And now that should, oh, and we need to debug it. Middle left, I keep hitting B instead of M. And then we're going to, so now we have the middle point. I just wanted to see the middle point should line up with each of these spots. What we got to make sure is that the green dot is within a rectangle that we could do proper collision detection for. As long as you don't, even if we had like, let's say for example, we came in and we made something where like this tile was empty. So like, I'll show you sort of what that looks like. Let's say that was empty and then we just had this thing floating. Since we're going to hit the top and the bottom, it doesn't really matter. We automatically know that we're going to have a collision. So we try to find the minimum number of points to test collision against to make sure that this works. So then the last we're going to do is bottom left. And here we'll do, this is middle left. We'll copy it. We'll do bottom left. And all bottom left is going to be is entity height -1. Or throw an error. Bottom left. All right, if you're just tuning in, we're just doing some fun with collision stuff. All right, so now we have that point on the bottom left-hand side. So what we want to look for is, all right, since we're only going to be testing collision on the face or the front of the player, we don't need to do all of the tiles around it. So like, for example, here, we can get rid of top right. We don't need that. We do need bottom though. So bottom is basically going to be, did I already do bottom? No. Bottom is going to be the top position, the top X, and then we're going to do collision point top Y plus the entity hit rect height. And I think we're going to need to do +1 here since the other one was offset. And we need to debug it. Top right, bottom. All right, there we go. So, in fact, what we want to do is it should just be, we can get rid of that plus and just leave it as is. All right, so those are the points that we really need to test, and the left side we're going to flip based on the direction of where they're facing. So just trying to think real quick of how I want to do that. Let's get rid of this top right and all this other stuff. Right, and now we just simplified it down to only calculating 1, 2, 3 points. And I could probably, I'll probably wind up just caching this onto the player or to any object that we add physics to, so that we don't have to do all right, let's see here. So we got top left, middle left, bottom left, top and bottom. All right, so all we want to do now is just make sure that when we go through and calculate these points that, all right, so here's what I'm thinking. If we pre-calculate all of this stuff, then we don't have to do any of that math flippy stuff. We just need to know which side to look for. And then we could save ourselves a lot of trouble. So, okay, let's do that. So we're going to do top right, middle right, and bottom right. Top right. I mean, luckily we're not running on a 1 megahertz computer like the Nintendo was. So I'm not, like, this stuff isn't going to, like, tax it down. And because of the way that we limit the amount of sprites anyways, it's going to work out fine. All right, so all we need to do is take the entity.hitRect.width and add that to the x value of all of these. And now, if we rerun this, we have all of our points, and it should match up to our reference material here for what they did on this Nintendo game. So, all right, and we just need to do one last thing, where this should just be -1, -1, and -1. All right. So there we go. So now we are, now we have the basic collision points. What we have to start doing is testing these collision points. And what I'm debating is, do I want to make it an array, or do I want to leave it as sort of, I hate magic strings. So this sort of frustrates me that we're using magic strings. I might make an enum or something like that. But all right, let's do here when we configure our physics entity. See, here's the challenge. If the hitbox changes, then we have to recalculate all this stuff. So I wonder if it's worth calculating on the offset. So let's do this. Local offset equals if entity flip h is true, and we're going to set the flip h value to 0, or to entity rect hit rect dot width -1. So all right, so let's go back to, let's remove this. And we're going to get rid of this debugging right here. And all we're going to do is add at the end of this our offset. So basically we're just seeing if the player is flipped, then we will do this. And as much as what I was actually thinking of is this. When we do sliding, that's actually going to change the hit rect. So we want to make sure that this is, unfortunately, it looks like we're going to make this sort of calculated on every frame. Maybe we could do, I'll come up with that. We'll optimize later. I don't know why I'm already thinking of optimizing it. So there is that. Why is that so messed up? It must be using the reference. Yeah, okay, cool. We just need to do it in one place. Winning. There we go. I see what I did wrong. We'll just have to remove the offset from the X position. And here we don't need to do that because it's already calculated. All right, there we go. So now look, so the green boxes are on the front of the player, and depending on which direction we move. The only way that this would like really screw us up is, I'm just trying to think through this. Like if we had a moving platform that hit the player from behind, it would have to push the player forward. But we're not gonna deal with that in this game. We're just gonna keep it basically simple enough that, you know, if we hit a wall like this, if we hit a wall, it just stops the player. All right, so now let's see here. All right, so now we got this stuff, and what we want to do next is we want to fix this collision so that it's. We're going to look for the. We're going to look for the bottom 2 points and make sure that they are on the ground. Actually, all we need to do when we're falling is we just need to test the center one. So let's do that. So I'm going to come back down here. And what we're going to do is, there's all this stuff I have here for like next position and test position and stuff like that. Now we can just go here and say, okay, we're going to test the bottom position and see if we hit something. So, grid position. I think what happens is when we calculate this stuff, we're not taking into account. We're not taking into account the next frame. So that's why you see here, this thing moves, but that green box is always one frame behind because it's not actually calculating ahead. Yeah, I'm running with you, running with the snakes. There we go, shot you. All right, so let's come back here and let's take one more pass at this real quick. Let's take our, we're going to calculate our next position. All right, so now we gotta use the next position here. So let's do this. Calculate next position. All right, and what we're gonna do is we're gonna take the next position X value. We'll start with just X, and then we'll deal with Y. But basically, the next position X is going to equal the entity's rect X, which we're already using, plus the entity's velocity X. And in this case, what we're going to do is, since this is automatically going to take the velocity into account, our test position is already figured out for us. So we just need to come in here and change. Oh, let me make this a little bigger. Wherever we see entity, wherever we see entity rect X, we're going to replace it with. Luckily, we only do this in one place. So let's change it to next position X. And then next position Y equals entity rect Y. We'll add in the other stuff next. But then here, so, and this is sort of why I set it up this way, is now all the stuff cascades, right? We figure out the first position. And then once we figure out the first position, everything else is based off of that first position. And we don't have to like do all the extra stuff over and over and over again. All right. So now when we move forward, you'll see that green area is now at the front of the player. Right? So here I can't move. It moves the green over. And then when I let go, it releases it because it goes back to its default position. All right, so now the next thing we want to do is go to sleep. That's the next thing. Let's add the velocity y. I have to accumulate gravity. So accumulate gravity, calculate next y position, calculate next x position. 49. Entity x velocity, entity x velocity. Oh, am I not calculating the delay? Delay is going to be our constant between each frame and how we keep everything in sync. And there was a neat trick in that article that talked about how they got around the fact that there's no floats on the Nintendo. So, all right. Right now, it looks like everything is off by 1. It's too far down. So what I want to do is jump is stupid broken. All right, so that looks good, and it's still flipping correctly to the right position. So, all right, next. Now we need to go through and rip out the old position stuff where I tested for old test positions. And we're going to go piece by piece and just... I almost feel like I should just remove all this crap. All right, let's comment all this out, and then we'll go piece by piece and add it back in. So, all right. What we now have is it's going to automatically calculate all this stuff, but we're not adding it to the player. So the player is no longer accumulating velocity, and let's go and add that in. So the first thing we want to do is test to see if, well, we sort of did this. If flip H, forget this. Update position on the grid, grid position. We'll deal with that later. Test for the flag and the position. Test position. So this is going to be, I'm going to set this to middle top, middle bottom, and we're going to make this top, middle, bottom. And we'll do top, middle, and top, bottom, bottom, middle. Right, so we have top, middle, bottom, top, middle, bottom, middle. 62. Right, because I changed all this stuff. So this is top M. Top M. Top. This is sort of the process of how I program anyways. Like I go like piece by piece, really slowly through, and just make sure that things are working the way that they should. What I want to make sure is that the middle should always be centered. Well, I don't know. We'll deal with that later. We'll see how that affects it. What I really got to get now is, all right, let's test our movement, right? So, so the first thing we're going to do is if entity velocity x does not equal 0, then we are moving, end. So what we need to do is, for right now, just to make sure that this works, we are going to get, we are just simply going to set the actually, I'm going to pull out this whole thing. This was sort of working fine yesterday anyway, so. All right, so if the flag is not solid, save the new X position. Right, so we rerun this, and now we can move forward and we can move backwards. So that's giving us our basic forward and backwards movement. Now what we want to do is test out whether the flag is actually colliding or not. So here we're going to create, we're going to update the grid position. And what we want is we need to do this. We're going to do local tests equals if we're moving to the right or the left, we want to basically test for 3 different positions, right? We need to test the top, the middle, and the bottom. And we're going to go through and do for, you know what, I'm going to get rid of the for loop because in all honesty, the problem is, if we do a for loop, Lua is like really slow for running for loops in the way that I have things set. Well, let's just do a for loop and then we can unwrap it later. I'm always thinking about optimization when I shouldn't. Tests. This is our most expensive test. It's just moving forward. Right? So, so what we're going to do is if flag value is less than 0, then end, and we're going to go through and we're going to set the flag value equal to should be like flag I, no, it's tests I math.floor test I x dot x divided by 8. And we'll do the same thing for y. And what I want to do is actually test out this collision. So here we're going to do physics debug. We're going to test out. There should be a grid position thing that I was using. Yeah, here we go. I'm making this more, like, I would optimize the hell out of this. I'm making this more robust so when I teach it, it's sort of clearer to understand how this stuff is organized. So normally I would probably just do this all in like one big thing, but breaking it up with like, all right, first, it's easy to explain. Like first we need to calculate what tile that grid X position is. Then we need to figure out the Y, and we'll get the grid position for that. Then we're going to go and test the actual flag value. We're going to get the flag value, and we're going to debug our value. Here we're going to just do test I, and we're going to pass in the grid position, right? And this will let us debug where we're actually testing. Let me see if this works real quick. Oh, hey, look at that. All right, so that worked. Sometimes I'm shocked when it works. Like now it doesn't work. Lua 15, attempt to index a nil value. Grid position, X and Y, debug physics. All right, let's get rid of this, right? All right, so now you see there's no collision that we're testing for. When we move forward, you'll see we're now testing along 3 points. And we're going to have to move these points up so that they're actually moving in the right place. And in fact, hold on, let me just spawn our player a little further down so that he's right. Like, so right now that shouldn't be moving through those solid walls. In fact, what we want to do is 90, 88, maybe. That's our goal. Our goal is to get him at this position. We'll deal with the Y velocity in a second. I feel like I want to move the middle one up by 1. In fact, I want to move all of them up, but we'll deal with that in a second. Because I think the bottom one's always going to trigger. So let's see here. Flag value. So what we want to test is that flag value doesn't equal solid value. So watch this. So now he's not going to move because that bottom area is actually hitting the ground. So what we can do is, let's do 2 things. First off, I want to take middle, and I want to move middle up 1. And I want to move this up 3. Boom. Right? So now look at what's happening. What we're getting is we're getting this solid we're getting this solid test. And actually what I want to do is we're going to redo this. we should actually test from the bottom up. So let's change the order of this from bottom, middle to top. Because the chances are better that you're going to hit something on the bottom first, and then look at how it stops, right? That's exactly what we're looking for. We've hit something, it stops. It doesn't need to test any of the other positions. It's simply going through and testing these. All right, so that looks good. The next test that we need to do is going to be this guy on the floor, right? And the Y value. Oh, this is so much cleaner. I'm so glad that I sat down and did this. I'm also glad that I found that tutorial. That tutorial is awesome. All right, so here we were testing for the X velocity changing. So now what we're going to do is see if entity velocity Y is greater than 0, then end. What we want to do is we're going to test now the, we'll test the center point. And we'll just assume that the player has to be on the center point in order for him to be on the ground. So we're going to literally do the same exact thing here. The only difference is that we just need one test. So we don't have to like loop through all this, but I'm going to copy this over anyways, and we'll just clean it up. So what we're going to do is local test equals collision point bottom. Our flag value is going to equal -1. We don't even need to worry about this. All right, that does. Oh yeah, my brain like shut off for a second there. All right, we don't need to do this. We don't need to do this. And we don't need these two ends. All we need to do now is take the flag value is going to be set to -1. We're going to get the grid position based on our test value. And then we're going to get the flag position based on the grid position. We're going to debug him falling. And then flag value, solid flag. Entity rect Y is going to equal next position Y. All right, so let's just see if we can get gravity back in. 119. There we go. All right, so you see right now it's automatically hitting the floor. I don't know why it's testing that value. It should be, did I pick the wrong one? Bottom. Bottom middle. Oh, look, it's so good. Whoa, it works. Look at that. The visualizing this like really helped. I was like really just sort of not understanding what the hell was going on before, but being able to visualize this really helps. And I think this is going to make a really awesome tutorial. Like my goal is to make one really great tutorial that teaches you how to build this sort of Mega Man-esque game in Pixel Vision 8 and then go from there. So, and this is going to be reasonable, so I'm going to use the same sort of logic for the Mega Man stuff. All right. So now what we got to do is jump, which is sort of not that great. What we should do is this. What I think we could do is if this does not equal 0, if this is greater than 0, and we'll do the collision point middle bottom, or we'll do the collision point. We only need to test one collision when there's movement. Top, middle. And now I should be able to jump. And you see the gravity is screwy. But it's now going up and looking for a collision. So like, let's say if I came back in here and we went into our flags and we let's just make that the collision area and save it. And now he shouldn't be able to jump past that M. Did I just screw that up? I hate when I do that. See, he jumps, he hits that area, and he can't really jump anymore. Now, we're going to do some stuff to clean this up because the actual physics calculation sort of sucks. But we are there to the point where... I did notice this one, which is a cool bug, where you can just keep jumping so high that it... but that's what I have to figure out. I have to fix the amount of fall that you have. Basically, it's escape velocity. But he hits the ceiling, and he can't get out of the ceiling now. So that works out well. So right, so we're testing, hit. We can jump. Jump over that. That was awful. Woo! All right, cool. All right, so what I'm going to do is I'm going to take a quick break. I just go have a little snack before I get all cranky like. Let's do back at 10. We'll do 10:18. Whoops, 18. And we'll finish. Next what we got to do, now that we have all the collision points working correctly, we just have to fix gravity and the velocity and the way that I calculate that, because it's just too much right now. Sorry, let me save this out and submit this, and we should be good to go. I'll be right back. All right, that took a little bit longer than I wanted. Sorry about that. Very important that my mid-morning snack. All right, so I feel like I'm happy with the way that the basic physics are working. Excuse me, at this current state. Excuse me. Oh my God, I keep burping. What I need to do now is let's go back and first off, I want to remove all this old crap code so that I'm not confused anymore. We don't need any of this. We don't need any of this. As far as I'm concerned, this is all the physics engine needs to do. There's some other stuff we're going to do that's going to be like nice callback stuff and syntactical stuff. But for the most part, all that we're doing is just testing out these positions and moving on with our life. Now, didn't want to cough in the mic, so I muted it. All right, so now what we want to do is just make sure that we are good to go here. Just wrapping my head around this. I wanted to test out one thing here. So if we do not hit a solid flag, great. I want to do this. Else entity velocity y equals 0. We should stop the velocity. And originally I had some problems with how this was like, it wasn't stopping in the correct place. It seems like that's now fixed because of where we're testing the tile. So like in this state, basically the player, if the velocity equals 0, the player is standing. And here, if we do this, the velocity x, that means the player is not moving. And we'll use that later for setting up the animations. All right, so what do we want to do next? Let's go ahead and let's see if we can fix the calculation we have for gravity and movement. Now, let's take a look at how they were doing this. Points 1 and 2, A and B are used for checking A, B, C, and D. Are used for checking left and right tile collisions. Only A and B or C and D are checked depending on the direction the kid is traveling. So I was right about that. Points B and D are checked for every type of object. Points B and D are checked for every type of object, but point A and C are only checked for the kid. Point T is used for checking collision when the kid is going up. Most of the points are adjustable in some way. Points A are always at the same relative height, but can be moved left or right together. All right, terrain, I wanted to skip. There was something else up here that I wanted out of this. All right, so object position in the game are 16 bits significant and have a resolution of 1/4 pixel. This is our decimal place and allows the object to move smoothly at various speeds. This provides that Mario feel. Some games force all monsters and the player to move on some integer multiple of pixels per v-blank and thus lose some of that fluid feel. There are two types of X movement routines. Routine is used when the object is in the air, and then the object moving in the air just uses normal physics for movement on the ground, we need to make sure the object follows the contour of the ground. Right, okay. So there are two things we need to do. First off, I think for the sake of sanity, my sanity, I'm just going to, let's come back. Oh, actually, let's look at the old game and let's just see how I did its physics, because technically I should be able to swap out the old game's physics and I should be able to swap out the old game's physics and then everything should sort of work. We'll test that out real quick. Where's the physics library here? So if I came in here and I set gravity to 10, and we changed gravity to time delta, and we clamped it at -5 and 5. Let's just see if this gravity works a little bit better. Whoop, 52. Why doesn't it like this idea? Oh, because I probably call it gravity here. Gravity multiplied by time delta. What is going on here? All right, I guess gravity's not working. Let's come back here to the micro platformer code entities. And let's set his position back to 24. All right, for some reason he's not falling. All right, gravity versus time delta. Let's set the gravity to 200 or 20. Let me get rid of this. I think the resetting the velocity to y screws things up, and I don't know why. I have to look back in the other example of how that works. Nope. Oh yeah, there we go. Why is... What I'm not understanding here is, and maybe it's because I'm clamping it. Let's get rid of the clamp for a second and just see. Basically, the entity's velocity should increase by the gravity multiplied by time delta. I think there's like a bunch of... Hold on, I gotta fix some of this crap. I think there's stuff up here that's also blocking it. When I was doing some like earlier tests. Let's get rid of this. And let's just save this out. All right. Oh, one thing I think is happening is that when I try to get the player to jump, what was the default jump value here? 3. Why is the hold on, I gotta print out this velocity and see what the hell's going on here. Print velocity y Why is this not working is the real question. Once I figure out this, so now this is the hardest part of any platformer, is just figuring out the equation for how fast gravity works. And then once you sort that out, then it basically becomes a platformer. Let's look at this and take a look at... whoops, I have some code in there that shouldn't be there. I forgot to get rid of that debug code. 54. So the velocity is set to 2. Negative, why is it setting it back to 1? So maybe somewhere around here it's, what? Entity y is greater than, So, okay, so let's sit here and figure this out, right? If velocity is y, but why would velocity y ever equal 0? I'm not setting it to 0 unless, I see. This is going to be stupid, but if it, sure, it'll just always... Why is this not now working? Shoot. All right, let me look at how I had this in the other physics, and we'll see from there. So if entity dy is greater than 0, if it's less than 0, but if it's 0, we still calculate gravity. Because the last time I checked, gravity multiplied by time delta. Because even if this hits 0, so first off, if this is not equal to 0, we will test that we're not standing. All right, let's test this out. So we're still calculating how much gravity to add. I know why. I know why. Okay, the problem is... All right, stop that. All right, what's happening is... We have to do something like this. Basically, we have to emulate the decimal point. So what I'm going to do is multiply this by 10. What was the second thing that I was tracing out? Gravity is 20. So I'm going to multiply this by 10, turn it into a whole number, and then when I set it, divide it back into 10. The reason is that basically when we apply the velocity here, Pixel Vision 8 doesn't understand what this next position y. See, I'm just trying to think of how to do decimal points when you don't have ints. Hold on, let me see something here. Simulate floats with ints. How to do floating point calculations with integers. You're saying the emulation is too slow. I guess you mean the emulation of floating point. The only remaining alternative is to scale the integers are not sufficient. It's fixed point math, but it's not exactly fast either. We use almost interchangeably float and double, and on ARM it gives you 5x performance. What is fixed point math library? Math is an obviously fixed point arithmetic. We're learning so much today. Recently I was working on an application that helps helicopter. I put off fixed point math because the application makes excessive use of sines, cosines. All right, this is more than I want to do. The challenge that we have right now is this. If I set next position and grid position, well, next position. Where do I set test position? Grid position. Next position. All right, what we want to do is we're going to change next position to a float. And let's get the math right. Let's get this thing working, and then I'll figure out how to do it more like how a Nintendo would actually. Nope, that still isn't helping. The other thing we need to do is the entity velocity y. So let's go here to where we set up our velocity y. And we're going to set this up as a x equals 0, y equals 0. So the velocity needs to, whoops, break. Math, or we'll just do clamp. Set this value, and then we're going to make this equal to 5.5. So we don't go past 5.52. How did I screw this up? Gravity, time delta. There we go. I still don't understand why jump doesn't work. And like why velocity, like just setting it to... Jump animation frames is grounded, entity y. So this here, we update the physics, we add the gravity multiplied by time delta. Maybe it's something to do with, what was it outputting for y value? It says something to do with, like, so right now it's set to 2, but as soon as I jump, it sets it to 0. So we went from 2 to -2 to 1, and then it goes to 0, and when it's set to 0, it still is not working. So let's see if I could just simply test out greater than equal to 0. Let's get rid of this condition real quick. And we'll always test out this velocity. Whoa, something is really weird with the way that I'm setting this. And I don't understand what I'm doing wrong here. It has to be somewhere along the line. So I was trying to be clever and use Pixel Vision 8's vector class, but like this, I'm getting to the point where it's like the ROI on trying to make this accurate to a making it accurate to a Nintendo is just not worth the time. Previous position we don't need. Test position we don't need. Gravity we have. Flag. right, flag value is 0. So let's set this, let's get rid of this stuff. Get rid of flag, which we don't need anymore. And solid flag we'll hold on to for a minute. That's still there. Okay. All right, so now our player falls, great. What I don't understand is why he eventually gets stuck at 0. So what I need to go through and figure out is the grid position. Grid position should be an int, that's fine. When we create the next position, that will be fine. Enter rect x, velocity y. And velocity should now be a float. And what we should be doing over each frame, and here's where the problem is. You can see it. Velocity y is set to 0. Even though we're subtracting this like 0.333 stuff. So what I'm wondering is if entity velocity y. Like here, we set the velocity to -3, -5. That isn't gonna, it's still not gonna, like right now, something is resetting the velocity y to 0. So am I just not paying attention here? Gravity. I got rid of that. So dy when we calculate gravity is the dy value plus gravity multiplied by time delta. And entity velocity y is now a table I can't tell if there's a problem here where the Lua stuff going to C# is creating a float and an int collision, and it doesn't know what to do. Delay, we don't need the delay. Let's get rid of delay and make sure this isn't screwing up anything anywhere. As far as I'm concerned, every time we move... Oh, here's what it is. Clamp. Clamp is going to return an int. That's the problem right there. What we want to do is just make sure we're going to do this the hard-coded way. So if velocity y is greater than 5, then end. Else if entity velocity y is less than 5, less than -5, then entity velocity y equals -5. All right, that's the problem. That was probably turning that back into an int, and there we go. Now our guy can run. All right, so what we need to do is we got to make sure that we're limiting it by a certain. We got to make sure that we're limiting this jump value. This is the other problem that I couldn't figure out before. Was like sometimes it catches it, sometimes it doesn't, based on its falling velocity. Let's set it to 3 for a second to see how that works. 3. All right, so the next thing we got to do is we got to come up with a correct way that when we hit something, if we go into it like this, that it pushes it back up and it finds the amount, how far off it is. All right, so this should be a pretty straightforward problem to solve. We can set this back to 5. All right, what I'm going to do is I'm going to try to get all these values working here with floats, and then I'm going to roll it back to ints. I just have to stand for a second. So if you hear the mic moving, the problem, I think it's important that if I am going to make Pixel Vision 8 this thing that teaches you how to build games like they were on old systems, I think understanding the difference between ints and floats is pretty important, especially because everything inside of Pixel Vision 8 uses an int. I think the end goal would be to make sure that the whole system is just int-based. I mean, there's nothing I could do about that in Lua, but then that's up to you to decide. That you just got to know that whenever you set a value back into Pixel Vision 8, that it's just going to be turned into an int. So one of the ways we could also do that, try to open the window, it's like really dark. Dark in my office today. One of the other ways that we can do that is, yeah, let's solve the first problem. Is basically whenever we detect a collision, we need to make sure that the player is moved to the right position. So let's do this. We're gonna see right here. We need to first off, let's set the entity velocity y to equal 0, and let's just see how that affects things. Was that a joke? Why is that not? Oh, I see. Oh, look at that. Nope, it's still giving me that crap problem. It's not as bad though. It does like that weird thing where it like hits it and then sometimes doesn't calculate it correctly. So if y is greater than this. All right, let's do this. The other thing we need to do is entity standing equals true. And what we want to look for is when we try to make the player jump, if standing equals true, then end. That'll fix the double jump problem. Oh, we don't set it. We don't reset this if it is not... All right, now it... Why wasn't it jumping before? Why? I'm like, oh, I see why. Because on every frame... if entity is standing, and this should be pressed. So here, if we press it, you'll see he's just going to keep jumping, and he got stuck in the ceiling. All right, the reason for that was if... What we wanted is, all we want to do is test here that if the velocity is greater than 0, then end. All right. Only stop. Only set standing when. Only set standing when falling down. So whenever we hit something, though, we do want to stop the velocity immediately. We just only want to set the standing flag when we know that we've hit. Now all of a sudden it doesn't understand. If velocity, oh, I'm an idiot. Getting to that point in the day where it's like, all right, I've already been up since like, I don't know, 4 a.m. and I can't think right now. So here we go. So now when we hit the ceiling, it's not telling it that it's standing, so it's not going to be falling through. Hey clones, welcome. I need a little energy. Need to start talking to some people. You guys can chat, man. Like, you know, I'm not the best at following the chat, but at least I want to make sure. All right, so look at this. Look at this guy. So I think what we're gonna have to do is, I think we might have to add in all the collision stuff, because that's the exact problem I want to avoid. Is since we're only testing the center, we're gonna have to test out all. We're gonna test out all the ground positions. Because even right here, it's not testing that out. So let's come back in here. We're going to add in the same code we had before, which is up here. We'll do this loop thing. And we'll add that to here. So if flag ID equals 0, local... I'm just going to copy this whole thing here. What we probably could do is I wonder if we can. Now we need two separate tests for when we're either moving or when we're standing. Grid position, flag ID. All right, so we're going to move all this into here, and what we're going to look for is the we're going to look for the bottom, the middle. This stinks. I think we are going to have to calculate all those positions. 18. What is this in? Code physics line 18. I must not have copied over all the ends or something like that. Let me pull this back out again. And now we'll get rid of this. Test. All right, so flag value should equal -1, right? We reset the flag. Well, let's do... So we're going to take this whole thing here. And now we're just going to test it for the other positions. We reset standing. Is there any way we are not tagging ground and checking if you're colliding with it? The ground is sort of tagged. It has a collision flag in it. So if I come back here, and I'll show you what I'm actually doing is there are flags that are attached to certain parts of the tile map. So I can sit here and say this is flag 0, -1, or empty means there's nothing. And if I come here and I preview the flags, you'll sort of see where the flags are. So all I got to do is just test, hey, at a certain point, if you're within a tile, what's the flag ID? And that's what I'm getting back here. So I am sort of doing that. It's just unlike like Pico 8, for example. Like Pico 8, you define the tag in the sprite, and I define the tag on the tile map so that you could reuse tiles and stuff. Let's see if this works. All right, so now we're not testing the right stuff. We could do... Oh, now we're stuck in a wall. All right, so let's get the right flags going here. So now this is, we're gonna look for the bottom. The, it should be, it's the top, the medium, the middle, and the bottom. We're looking for the bottom and the bottom middle. And the bottom middle. We'll start with these two, and then we're gonna have to come up with the other side. Yeah, it's no problem. All questions are good questions right now. Okay, so now what you're seeing is the left hand side as we go through. So that blue box that gets highlighted is just me drawing the tile that I'm querying. The green box inside of it represents the point I'm actually testing. So I can just see it. So right now you see here we're getting a collision on two ends. Now if I was to jump and hold on, I got to my keyboard doesn't have arrows. So now we have so here he's going to move, and then all of a sudden he's going to be stuck in this wall. So, well, that's because we're not testing at the left side. All right, I think I'm going to have to go through and come up with all the points we need. So there you go. That's what you'd get where the guy's just literally standing on half it. All right, let's do this. Fucking annoying. All right, what we'll do is we're going to copy over the same ones. And then we'll add the flip offset here. And all the flip offset's going to be is the width of the rectangle. We're going to remove this from here, flip offset. And then I think that was the only place I was using the flip offset. So I think if we just add this to here and fix this correction. So this is a top. I got to redo all this crap now. This is top left, middle left, bottom left, top right, middle right, bottom right, top middle, top bottom. And then here what we need is this is all top left, top left, top left, top left. The dog, man. What the hell is he barking at? He sees like birds that go in the backyard, and then he wants to like go attack them, but he's A, too slow to get a bird, and B, even if he got a bird, he wouldn't even know what to do with it. It's like that line from the Joker where it's like, I just want to chase, I'm like a dog chasing cars. I don't know what I do if I get one. I just do things. That's my awful Joker impression. Top right, top right, top right. All right, cool. So now here what we're going to do is we're going to test. What we're going to do is we'll do something like this. Local direction letter equals if entity dot flip H is true, we are going to use the left side or right. So here we can be creative and mix this up. And then if we're testing this part, we're going to do bottom left, middle, and then bottom right. All right, try to make the system as generic as possible, because what I want to do is create like a nice little simple library that one, I can teach tutorials on for making 8-bit games, and then two, maybe just build into Pixel Vision 8, and then you guys can like have just a standard library for doing basic physics and stuff like that. 76, what did I break here? Top, middle, oh yeah, right, this is top left. Top left. Whoa, 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 whoa. Whoa, whoa, whoa. Go get him, George. Go get him, George. Killer. There's no flip offset. '86. Didn't like this idea at all. Bottom left, middle left, top left. Why don't you like this idea? Oh, Lua, I hate you. Oh my God, I hate you. You can't add plus to a stupid two-string, to concatenate two strings together. Fucking worst. Such an awful language. Can someone remind me why the hell I use this language for this engine? Oh, look at this. All right, there you go. So now you know. Oh, look, so now you get that like that really good where you're like right off the edge type of thing. And when he falls, he no longer falls inside of this area. All right. It's just, this is more complicated than I signed up for, but this is, I mean, according to this blog post, which if you guys weren't tuning in earlier, we were reading Greg Mann's Programming MC Kids blog post. This is how he did Collision on the Nintendo, and it works. I don't know what that like jaggy stuff is. So what's strange is that when he goes up, he's not testing. When he jumps up, he shouldn't be testing the bottom. Something's wrong here. Right, that's what we're missing. I think this is what we need to do. If entity velocity y, oh, look at that shit. Come on, Jesse, focus on, let's do this in the right area. That code actually works. Here, what I was trying to do is combine the y. Bottom left, bottom middle, bottom right. What we want to do is this. Blah, 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 blah. If entity velocity is greater than 0, we want to use the bottom. If not, we're going to use the top. And that means we use the direction letter. All right, there we go. So now you see when he jumps up, he's looking up. And let's go, like I was going to try to find a hallway. We're going to have to fix that stutter. I'm going to fix that stutter. The stutter will be fixed next in... there we go. Okay. So now he hits the top there and he dies. Oh, not dies. Whoa. That's what it should do. But like, it's these little edge cases like right there, right? Boom. He hits that area and he doesn't go through the wall. I mean, he technically doesn't jump high enough to... Whoa. How did I... All right, there's another template below it. All right, and this is kind of cool. I mean, it's like janky, but we're gonna fix that. Basically, what's happening is that he's falling. I wonder why it's like here it's smooth. He's falling into the pit. He's falling into the ground, and then he's being reset. He's not moving fast enough for it to... Alright. So you can now get stuff like this where he's like right on that edge and can jump. So you can time that correct. Alright, but it's good. We're getting better. So now the next step is that we need to basically calculate how far, well, once we hit a tile, we need to just bounce the player back. Oh, look at that. Fun facts, the memory for the tile map loops. So it, you're just seeing like other stuff that's off the memory buffer. Cool, all right, so, all right. You can see right here, he bounces a little bit, and that bounce is what we're gonna fix next. I left all these, I forgot to get out this, I was testing out this morning to do custom flag colors, and it's now working correctly. So like if you come down here, you should see red. Before, Pixel Vision 8 limited your colors to a certain grayscale, and it's like super hard to use. But now it's all working correctly. There's a lot of good little fixes in this. I was gonna release the next build next. I was gonna release it at the end of this week, but what I actually really like doing on these streams is like as I'm building out games, testing out the builds with it, and I'm always running on the latest build. So what I think is, even though I don't know, we'll see. I would like to have an extra week of. I should be able to finish all the bugs on this trip. What I love, I'm going out to Seattle tomorrow for work. And what I love about going out to Seattle is that since I wake up at 3 o'clock New York time anyways, that's like 1 o'clock in Seattle. So I sort of get up at like 1 or 2 in the morning and then just like code in my hotel room. But there's not really much else to do. One of these days, I'm actually going to use my weird sleep schedule to my advantage. And I thought about just going out to a bar at about 2. I think that's usually like last call in Seattle, but Seattle's lame. But like whenever I'm at an event or something like GDC, right, and everyone's going out and they're like partying and stuff, the downside is that I usually make sure I'm asleep by like 6 or 7 in Seattle, like old man style. But then I can get up and code in the morning, and I can get like a full like 6 hours of coding before I even have to get into the office, which is awesome. And since I leave the office around 5, I just have like a quick dinner and then just go to sleep. What I want to do one of these years at GDC is I'm going to keep my normal sleep schedule, but then when I wake up at like 2 in the morning, just go out and join the people at the parties. I don't think I can stay out all night and party, but at least I'd wake up and then for breakfast I'd go drink. Guess that's what I would do. That'd be weird. Wouldn't be the first time. It's not something I want to make a habit of, that's for sure. All right, let's get rid of... right now, this velocity stuff is working. The big problem we want to solve is the big problem we want to solve is we're going to need to go through and fix where we stop the player from walking. So let's start with y, because this is really the big problem. What I want to do is we're going to take this grid y position, and when we hit something solid, let's print out the what this value is, and let's just see if it's consistent. Yep, perfect. That's all I needed to know. Now that it's consistent, even though he's like, you know, like bouncing and stuff, we now know what tile to always realign him to, and we can use that position. Now, ironically enough, now all of a sudden he looks like he's not falling through the floor like he was before. All right, we're gonna add some stuff in here just to make sure that this always works. So now we have oh wait, actually what we want is we want it here. And only set standing when falling down. Oh no, okay. Oh yeah, right. All right, so when we hit a 0 velocity, in fact, let's do it this way here. I have a feeling that that was... I need to do something here. What I want to do is just do jump. All right, I just want to test that I was still running. For us, I don't even know how to code, but I like to watch this. Oh, I'm glad you like to watch this. I find this boring. I don't think I can watch anyone else code. Sometimes I'm like, sometimes I get like, there's like 3 states to streaming code. Sometimes I'm entertaining, and if I can tell, if I'm not doing something complicated, I can like when I'm doing pixel art stuff, I can talk and tell stories and be entertaining. Sometimes I'm like, I guess, educational with the code, and like able to like, it's not complicated enough to walk through. But when it's something complicated like this, I don't feel like I'm very interesting because I'm trying to like, my programming style is to really just like throw shit against the wall until it sticks. And I feel like that's like not much fun to watch. Like, hey, let's try this number. No, let's try this number. No, let's try this number. Let's try this number. Let's try this number. So, all right, what we want to do now is we want to make sure that our guy is always on the right position. And what we should be able to do is collision point. What I want to try to figure out is we're going to look at the bottom middle collision point. And I just want to see the difference between the ground and the bottom middle point. And what we're going to do next is take the difference of these and then shift the guy up in that direction. And it's printing out as a pixel vision vector. Why? $112. All right, so these two things work. What the hell's going on? Like, all of a sudden now it's running correctly? Like a minute ago, we were getting like that weird jaggy thing. There we go. Now it's the Y position. There we go. See, the Y position isn't correct. The guy is set to 113 and it's 112. See how he fell through the floor there? here it got fixed. And then all of a sudden yeah, you see it's like totally falling through the floor and stuff. All right, so let's see if we can find a pattern here real quick. 12, 13. All right, here's what my gut's telling me. This bottom collision point should never be lower than the ground. Right? So what we're going to do to preempt that is we need to figure out how we calculate the bottom middle point. Where's its y? So we're going to take the top middle point, and we're just going to subtract the entities hit rect. My theory goes like this. We should be able to calculate. Let's do this. Local new y equals the collision top middle point. Actually, we do collision top left point, because that is our registration mark. Wait a minute, what the fuck? What the hell's going on here? Let's see if we can just do this. Entity rect equals entity rect minus this. Let's see if we can just subtract the difference between where the ground position is and this guy's position. What I don't want to do is go back and like backtrack all of the values, and let's get rid of this. So whenever we hit, okay, it's going to be right here. Whenever we hit this ground, we're going to readjust the rect position. That just broke fucking everything. That broke the universe. What just happened? Diff. So let's get the entity rect position. Like what's happening is that when we're falling, we're setting the rect position, right? But we're not resetting it to snap it to the grid again when we hit the ground. So now let's take a look, and the difference is 0, 89, everything should be fine. So what we should do is, let's go here to where it was like screwing up. Oh, I see. So right here, the difference is -1. Right? We got 0 here, and everything is fine. When he walks, he doesn't stutter. When he gets here, it's -1, and you see he jitters like he's on crack. Like sometimes it works, sometimes it doesn't. But that's all we need to do is we now need to shift this guy's Y position by 1. So Y entity rect Why this didn't work is beyond me. Grid position. I have a feeling that this should only happen if we detect that there's a difference between it. So let's try this again and see if this... Well, that's cool. He just sort of like walks up shit now. All right. Why not? Well, but he still gets that weird jiggle. What's up with that, man? Why you broke? Huh. That's kind of cool, though. Now I know how to get him to, like, auto jump over stuff. Alright. Is that what I want? Not what I want at all. Only sit standing when falling down. I think it's here. This is where we need to put it. I'm too stoned. What am I watching? You're watching me struggle through building a physics engine for a Mega Man game. And my guy appears to be stoned too, because he's just... My physics math sucks. Why is this so crappy? Let me test the middle position. No, I am testing the middle position. Why? What the hell is going on? All right, now he stopped. There's like a weird thing that's happening here. I want to test one thing real quick. Let me get rid of gravity for a second. And let's see if that jitter happens. It's just, I just got to figure out the right place to where I need to reset his movement. So that jitter only has to do with the fact that he is falling. So what's funny is I think setting gravity to saying, oh, there we go. That's an awful gravity. Gravity is too strong. I can't jump. All right, let's set this back to 20 for right now. Seems to be the magic number. All right, so what I'm trying to figure out is if you're standing, we probably shouldn't test. What am I missing here for this gravity crap? Well, gravity is always applied, so we're fine here. And the velocity. So then the next position y, entity rect plus this. What I feel like is before we set the next position y, If the flag is not a solid flag, fine. So what we need to do now is, if velocity is still greater than 0, we set the standing, and then I just want to like move the player back 1. Entity rect y equals entity rect y minus 1. All right, so now we're going to get the bounce because he's not connecting correctly with the floor. But what I want to see is, yeah, it's amazing. It's like once you get past the first template, everything gets shifted down for some reason. And I don't understand why. Why he no longer moves smoothly over here. Well, it's very clear that I suck at doing physics math. That's for sure. Let's get rid of this. I guess what, like, maybe, where can, let's take a look at how Matthew did this. All right, so the player is falling. We look for the flag. We set the flag, and then we set the player's y to player y plus 8 multiplied by 8. So he recenters the player on a whole tile. Now, I don't think that works here because where else was he setting this y value? Looking for a solid tile. If it's on a solid tile, play it on top of the, set it on top of the tile. All right, so what we need to do is we need to do the real math here. I can't just keep cheating here. What we need to do is take the grid position y, and we're going to have to rebuild the height of the player. So basically this would be local new, or offset is going to equal, well, actually we'll just say shift y will equal the grid position x multiplied by 8. So this will be the top of the tile that we were just testing. Then from there, we're going to subtract the entity dot hit box height minus entity hit box y. That'll do the offset, and that should get us back by reversing what we did here before. Hit rect, not hit box. Can't type. Shift Y. So now let's just set the entity to this position and see what happens. So when we set the velocity to 0, we're going to remove the player back to the top of the tile. Oh my god, I want to scream. And now it does this crap, which I don't remember why it does that. Or not remember, I don't even know why it does that. What is going on here? So if it doesn't hit a solid tile, we're just going to move the player down to the next position. This should make the player just fall through the floor. All right. Why is... trying to see if it's consistent, which it's not. What I'm trying to get to is that on every frame we're going to move the player. What I want to do is fix the next position. If the velocity is greater than 0. There's a lot of like little things I need to just test out for. I just got to go piece by piece through how this gets calculated. But now I'm back to this shit. That's fine. All right. So let's get rid of this. Let's get rid of that. Entity rect equals next position. What I'm kind of confused about is how he actually... like, why does he fall through the floor so much? All right, so what we're going to do is this. Let's get rid of this for a second and see. That'll make him fall through the floor. Fine. All right, so if we hit a solid flag, what we're going to do is set the velocity to well... all right. If entity's velocity is greater than 0, and no, you know, no matter what we do, as soon as we hit a wall, we are going, anytime we hit something solid, when we're moving down, we are just going to set the velocity y to equal 0. Which makes him stuck in here now. Brilliant. Then what we want to test is, right, if, let's just copy this out and we'll move this back up here. So we're back to where we were before. But it's fine because what we're going to do is once we stop and we're standing, we're going to take a look at what that value is of where we feel the player has stopped versus where he should be. I just want to see, all right, so he's still not stopping at the same places. So let's do this. Let's print next y. We'll print the next position y and see where that is versus the grid position y. So you see, the ground is always the same position, right? But the player is not stopping there. The player is always at these like different versions of where that ground should be. And even more interesting is that it's still, look at what it's calculating there. So what I'm kind of confused about is, all right, so let's do this. Let's try to simply set the next Y position back. Next position minus entity hit rect height divided by 8 multiplied by 8. All right, 80th time is the charm. All right, so that's too high. I think it really has more to do with the difference between this value Why is he jumping so high? Ground is still ground, right? So that's 112. So what we want to figure out is the real base is this value here. So let's take this minus the height. So now it's consistent, but he still moves down a frame. All right, let's do something just, I'm just like, this, again, here's how I come up with these answers. I just want to try to get this to where it, I don't know, works. That would be awesome. So that's moving it too high. I think to there we go. There we go. Although we're getting that thing again, but I can fix that in a second. I think it has something to do with the way that the we're doing the collision, but I think I know what that is for. What I want to see is if we get here. Nope. Why the hell does this jump all of a sudden? Like the core mechanic is there. It's just sometimes it jitters and sometimes it doesn't. I wonder why he stutters. I don't know if you guys can sort of see it maybe on the stream, but he's just, no, run away, run away. Bam, bam. All right. All right, well, one thing that we've done, you know what I want to see here? Are we at the bottom where it says 112? Let's see, 112, but when it gets to that stutter, it's still 112. Let's make sure that this is always changed here. What's interesting is that I think what's happening is we get to a point in the template right here where it switches over. And the hold on one second. My dog felt like joining me. I feel like it gets right here, and you could see it stops like testing. It stops testing correctly. Like right now, it's falling. I think. Oh wait. Well. What I want to do is this. Flag value. All right, there's a lot of things my brain's trying to figure out right now. One, the problem is when we're falling right now, what's happening is the player is not testing all 3 points. Because if we come here and we take a look, velocity, I gotta go clear the log file. Hold on a second. This is going to be generating out this like massive log file. Where's the temp? Libs temp. That's only 3.7 megs. Oh, you're still updating this. Stop that. All right, so what I got to figure out is, all right. The first problem I have to do is that we need to test out all 3 of these positions. And should be, if we set this value to 0 and we set the flag value equal to flag value plus flag, this flag value should still equal 0 at the end of the day. All right, so the first problem I want to solve is that when he falls, that he's testing out. Wait, am I on the wrong one? Like an idiot? This test, flag value should equal 0. And we will do flag plus flag. Well, that did shit. I think it just like fell off the earth. Here's why. My approach was right. I just had to get rid of the condition here. All right, so come on. All right, so now what we're doing is it's testing out. There's a little bit of jitter. That's just the basics part of the physics engine anyways, but what's happening is it's going from the top to the bottom, and as soon as it goes to the bottom, it hits that, and it automatically has our collision. That should fix this crap, where I can't like scale up the wall by just walking into it. So that's the first one. But now it's not testing Now it's not hitting that at all. I don't know why now all of a sudden. The only thing of it is that it's like stupid. Why is he not colliding with the bottom now? When we're going down, we want to test all those points. And if we hit any of these points, we immediately stop the player. Let's get rid of this where we reposition it. Maybe there's just something here that's like screwing up. Well, now he's just like fucking stuck in the ground. Yeah, like that's such a weird little bug where he just like falls through the ground. What I'm even more concerned about now is why... Let me go back to this for a second. Because now I'm even more concerned about why he doesn't stop on platforms. And at what point did I break that? Alright, so now he's standing on the platform. Right? We only need one collision. I think that's... Like right there is the crux of the problem. I think the ground is down one lower than it should be. The middle one. Let's see if we can fix that position. The bottom middle, let's set its height -1. All right, so now he's at the right. Now he's testing all these positions at the correct area. Now he's got to fix the how far down the rabbit hole it goes. Sorry, I think the easiest way to fix this solution is to say, what is the difference between? Right now we're gonna find the difference. Now we want to find the next position y and the grid value. 68, 68, 28. That's too much. Next position y. We want to get the middle position y. Ground. Local diff equals, we want the middle bottom. Bottom middle. So we're going to take the bottom middle position. Then we're going to take the actual grid position here. How's progress going? Good. Welcome. I'm getting close. I'm getting close. What we want to do is figure out what is the difference between the y value minus what we're testing here. Let's see what this yields us. I'm very close. I'm just trying to fix some of these, like this little. Well, that's a big bug. 157. So the difference is 2. So he's 2 pixels down than where he needs to be. Let's jump. Now he's 1 pixel. Now he's 0 pixels. 3 pixels. So what we want to do is take the difference. We're going to take the next position minus the difference and see if that fixes our problem. Right now I'm just trying to get it to where he doesn't, we do some calculations to make sure he doesn't jump to the floor. 161. All right, now we're back in business. All right, so what I want to do is, the problem here is that he is... All right, so here's what we got to account for. He won't move left or right now because he's in the ground, which is fine. But like if we were to do like -1, he'll bounce. Now you're not seeing the bounce. So that pushes him back 1. What I don't like is this like weird, like that jitter, and I got to figure that out. But let's see. If we come here, it looks like we're getting much closer though, because now the jitter, that jitter has more to do with the fact that it's the left and the right collision stuff. So watch, like if I got rid of the testing on the X and Y position, like here, if I get rid of this, nope, I lied. Let's just pretend like there's no, there you go. So now he looks like he should as he's moving. The problem is we're testing out the collision flag, and we're getting to the point where we need to just make a slight adjustment to that. Get away, get away, get away, get away. Oh, that's annoying. All right, we're getting closer. Now what we got to do is we just got to make sure that when we go to test out the position. So here's what I want to do. I want to try something here where we take the we take these values here and left, middle, right, and what we did was take +1. +1. Let's see if this, now when we fall, we're going to test. There we go. All right, so what we did was we are now testing one below that value to make sure that we're good to go. And now our player stops. I did add that code back in and everything. Well, he is stopping at the wall. He's not floating over the wall again, so that is a good sign. Yeah, okay, we stopped the velocity X. We stopped the velocity Y, and we are standing. Now, I think that we could just use the last test position. Where was tests? So we'll use the middle test value. And then we set the velocity to 0. All right, I think I fixed the physics. Oh, I fucking broke. Ah! What the fuck? I need to go set the flag so I can curse on this show. I am not cursing enough to deal with this. The amount of math I've had to do this morning. All right. He's moving. Everything looks good. We'll have to fix that crap. But basically, that's what we're looking for. Whoa. All right. And now we're in the ceiling. I would love it if I knew how the hell I wound up in the ceiling. That's awesome. All right, let's do this real quick. Let's only fix this when we hit the ground. I think when you're moving up, it's not going to matter. There we go. Yeah, all right. It doesn't matter. All right. That's what we need to do. Whenever we consider the fact that we hit the ground, we're going to stop. Now we can run. All right, so let's try this. The real trick is, can we actually... All right, so he's off by 1 pixel from where I want him standing on the floor. So what I'm going to see if we could do... Oh, I had to fix my back. What I'm going to see if we could do is, let's see if we can add 1 pixel to the collision rect. So we'll go to our entity here, and when I set up the... where the hell do I set this up? Configure collision. Let's move it down by 1 pixel. All right, perfect. That worked great. So now you can see his feet are right on the line of the ground, right? Like, and we can fix that even more. Like if I move this down to 6 and redid this, now our guy's standing above the ground, right? And all we're missing is his collision box is a little too small. So if we actually went back to 4 and 2, I'm actually going to make this 12 and 6. The red box in the background, by the way. So now look, when he moves, he's in this area and he looks good. I can remove the debugging stuff and we'll see that he's not doing any of that jitter crap that we had before. He can now hit ceilings. He doesn't do that weird, like, get stuck in the ceiling jazz. He does get stuck on the floor, but that's more because there's actually a tile below him that's solid. So he does hit the tile correctly. And we're just testing all kinds of crazy. See all those like flashing boxes? It's like, what grid tile are we testing? But I think this is good. The next step of what we would do is probably we would want to come up with a way of telling the engine what to do when it hits certain tiles. And we could actually do some more interesting things like this. So for entity to entity stuff, hold on, move the mic up. I was standing. For entity to entity, we're doing just straight bounding box. Each guy has its own collision box. It just makes sense. I don't have it hooked up for the player hitting the enemies yet, but that shouldn't take me too long. The physics engine was really just sucking away all my time. Maybe what we'll do is we could take, I don't know, it's 12 o'clock. Let me see what my schedule looks like today. I think I have a meeting at 1. So I guess I can just have lunch and do my meeting. And I guess I'll cook lunch while I have my meeting. All right, so just pulling up my schedule so I can see what my meetings are today. Yeah, I have a meeting at 1. Let's let's just power through this. Let's see if we can get well, we're not going to be able to see much of the collision. Let's see if we can. What we need to figure out now is the animation states, right? And I think if we get animation states based on physics, we should be good to go. I'm feeling pretty good about the physics here. Again, this isn't going to catch all of the strange edge cases, but it will allow you to cover most of them. I think right now, we could, well, I don't know if I don't think I'm in a math mood. I did want to change this back to ints instead of floats because I was cheating. So there's some other stuff that we need to figure out, but I think we can get each of the animation states. I'm just trying to I'm just walking around seeing if just shit breaks. Well, that sort of works fine. That's a good one because the other level is literally right below it. So if he was going to fall in, so right there you're seeing that that's the one problem we have where we're not readjusting the top bounce. So you hit a wall and then you can go, you sort of go into that wall. There's some other ways that we could fix that by adding a little bit more padding to the top of his head. But I think, when it comes to something like this, where you really saw it was when he hit the floor and went through the floor. But all right, this is cool. I'm I'm finally feeling good about this. That that wasn't bad. What was it? Let me see. Let's see what my timer is here. 3 hours. And I did most of it yesterday, but that's fine. This probably could have been a lot easier. All I really needed to do was worry about the bottom and all I had to do really is worry about the bottom. And I could have actually been done with this a lot faster. The other thing that we could do here, all we're getting now for the velocity X is 1. We should be able to do something well, he doesn't increment velocity over time. When he runs. So that's something else we could do. If we made his velocity 2, you'll see now he runs a lot faster. Whoops, did I just run into a wall? So this is the problem with doing the velocity as an int. We don't get any of that fractional stuff that we really want. Something is making it collide here. Oh, you know what it is? Ha! No, that can't be right. Why? What's going on there? It's I wonder what template was this? Template 13. What's going on with template 13, buddy? All right. That's weird. $8.11. I don't know why all of a sudden it's now. Well, now he's dead. That was weird. Huh. There we go. Just as I thought I had everything worked. Now he's floating. What's kind of interesting is if you look at his collision box. His collision box is a little far down, but he's not... the points aren't where they're supposed to be. Now all of a sudden 10 is fine. I wonder if it has something to do with the fact that the I have a feeling like I have to wrap X. Here, we can do some quick math and test this out. All right, so my theory is that when it gets to the end here and it loops back around on the tile map buffer, that it loses its focus on where we're actually testing. So let's do this. If this is 1, 2, 3, 4, 5, 6, 7, 8, roughly around 9. So if we have 9 new screens, it's going to break. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Try that one more time. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Once we get to 9 screens. All right. So that has more to do with next X position. I was doing this before when I was testing for the flag stuff. Where is this in the original game? I thought I didn't have to deal with it, but I do. Basically, we have to get the map size. So let's get the total map size. Right? And then when we go to calculate the test, we need to repeat the test position Y. Map size, yeah, here we go. Test position X. So when we come in here and we calculate the grid position X, we need to do this. And I believe we need to do the same thing for down here. Right? All right, so let's try that again. Playtesting. It's the stuff of nightmares. And as soon as I release this code, someone's going to use it and totally find a way to break it. 3, 4, 5, 6, 7, 8, 9, 10. Math is great. 11, 12. Perfect. That was the problem. It was just going off the grid and it couldn't figure out the problem. What you got to understand is it's wrapping back around itself because there's only a limited number. There's a limited amount of tile map memory that your game can have. So basically, you have to recycle the tile map as much as possible. Like if you go back, it'll start. It's hard to see now, but it depends if you catch it on the seam. It'll like literally just like start rewriting parts of the map. It should actually be pretty seamless once you get past the first stage. So, all right. I think physics are good. Let's do the last thing I promised was let's get oh well. All right, I'm gonna figure out the X, the horizontal scrolling at some point. Like this is, I don't know if you should move at 1 pixel per. Excuse me. Like, I feel like this should be an incremental thing. Like, you give it a speed, and it, like, over the course of a frame adds to it. But this is, like, really... Well, this is too slow, and the other's too fast. And we need to do the fractional stuff. Like, this is almost... This is literally only moving 1 pixel per frame. And that's not how these games worked. So, all right. We'll deal with that later. What I'd like to see right now is, can we get different animation states? And here's what I'm going to do. I'm going to call create local states. Whoops. States. We'll do idle. Now this is like, this stuff I'm used to doing. Idle, walk. I've done this stuff a million times in Unity, and I've written so many like tutorials and books and stuff on this. Player walk 1. So let's see if we can just knock this out real quick. It's not going to be perfect, but I just want to see if the same stuff that I've done in the past will apply here. We should actually do the animation in the right order before Andrew gets upset with me again. Whoops. Jump, player jump. What was the other thing I needed? Fall. My brain's thinking about eating, so like now I'm like totally... Hopefully this isn't like too mentally taxing, because I don't think I have it in me to... I don't think I have it in me to like spend more time debugging this more than I have to. All right, so that's player fall, and then what we need to do is copy all these and jump, fall, idle, gun, which is just gun. So there's a thing where if you have the gun or you don't have the gun, player jump gun, player fall gun. So these are all the animations for the player. I'll come up with a cleaner way of doing this, because now that I see it, it's going to drive me nuts. And what we want to do is, after we update the physics, we're going to test to see what... Whoops. After we update the physics, we're going to test to see what the animation should be. And if we look at the entity manager, there should be a... Well, I had it before. Where did I delete? Configure animation. We're going to look for frames, and we're going to pass in the right value. So I'll show you sort of what I mean by that. So well, the first thing we're going to do is see... all right, so if... would I recommend Game Creator Pro for a game jam? So... since I'm the one who wrote the Game Creator Pro, yes, the whole reason I built this was for game jams and to be able to build like really authentic 8-bit games, but during game jams. That's what the Game Creator Pro is for. The actual SDK that runs it is a lot more powerful, but it's pure C#. This is just gives you like a lot of debug tools and stuff to sort of help you out. The thing my caveat is that there's still a lot of little bugs and stuff I'm working out of it. So, I would wait until I have more documentation. That's really... the problem, is that I'm the only person who knows how to use the engine, so it may not be the best for people getting started. But once I finish this game, I'm going to rip this whole thing apart, turn it into a tutorial, and talk about literally every aspect of Pixel Vision 8 and the Game Creator Pro. And you'll have everything you need to know if you follow this tutorial to just understand the core mechanics. And then I can't help you from there. I can only hold your hand for so long. Let's see. So speaking of hand holding, let's get the animation going for our guy and teach him what his animation should be like. So, all right. So if entity velocity y is greater than 0, then local new state equals idle. Sorry, some texts are coming in. All right, so then else if velocity is less than y. All right, so new state is going to be, new state's going to equal fall. Right? All right, so we're going to do fall. So if the player is, if its velocity is greater than 0, that means he's falling down. If his velocity is less than 0, that means that he's jumping. Else if, all right, so those are end. The next step is, we want to, well, let's just try these two things real quick and see if we can get a, then what we'll do is an else, whoops, whoa, I started doing C# there for a second there. What we wanted to do is I wanted to set the entity frames to state new state. All right. You can sort of see it. I got to get rid of the debug. Let me get rid of the debug stuff. It's a little too distracting. There we go. He jumps down so fast that it's like hard to see, but he is now changing his jump state based on whether he's falling or not. Let's see if we can get up higher so you can. Yeah, that looks good. This is like a little this is a little system that I came up with Unity like a while back, where when I first started playing Unity, it's just checking the velocity. I mean, this is nothing new, right? I mean, I'm not saying that I invented this crap. All I'm saying is that this is how I've done it in Unity since like for 5 years now. Is when I was using Unity's physics, I would just simply test to see what the velocity looked like and go from there. So now what we want to do is if the entity.standing is true, then else end. Right? So now we only want to change the run animation based on whether we're standing. Entity, so then now if, we'll do the same thing here. We'll just change it for X. If entity, so let's do this. Math.abs. Entity value is greater than 0. Then the new state is going to equal walk. You know what the best part of this shit is that I don't have to like use Unity's awful state machine connecting thing. Like I've never in my life have I seen something that's so complicated to do something that should be so simple. So angry. So angry at Unity today. Like, over the weekend, again, I tried to upgrade to Unity 2017, and like everything breaks, and I have no clue why, and I have no patience for it anymore. Whoops. 120. Oh, 2 maths. I hate, like, there's something, this, is there a new update for this thing? Hold on. Where the hell is, preferences, packages, updates? I think this Lua package is broken because now when I try to do, like, if I do math.abs and I hit enter, it does math twice. I don't know what that's all about. All right, so perhaps he's not standing. Oh, I'm an idiot. It should be X. I forgot. I said I was going to copy it over and change it, and I didn't do it. Look at that. Bam! We're walking. Jump and shoot, man. And he's shooting. I just got the wrong animations. Jump and shoot. That's what the game should just be. It's like an endless jumping thing. Yeah. Oh, yeah. Wow, man. When the physics work, it's good. It's amazing. Not for nothing. I struggled a little bit with it because I really didn't look up much reference stuff. But not for nothing. I mean, the physics for these things are pretty simple. Like, these games were so simply made. Only because they didn't... There wasn't like a... Oop, as I open my big fat mouth. Oh, that's annoying. We'll have to figure out how to fix that. He's stuck on a wall. Well, the only way I can fix that is if he hits a wall, I should push him back. That would basically, once you hit that, it would basically fix it. Okay, yeah, whatever, we can fix that. But cool, like we got like real animation going and different states. So let's do this. Now let's get it to where... Ugh, I gotta fix my keyboard. What we're looking for is, for right now, let's just do gun. And we'll add gun to all these states, and later on we'll go through and we'll fix that. Just running through all that stuff. I'm invincible. Whoops, that sucked. All right, so this thing should be cool. Like, look, I made it where when the turret's down, its collision goes away, and then it comes back. I've been having a lot of fun with this. I mean, I should have enough pieces now that I can actually just repackage this up exactly how my Ludum Dare game was, and then at least just offer up a version that isn't like completely like a hot mess. We should change... It looks like he's shooting out of his hand. We should just change that... the position thing. Again, I don't want to... well... I don't know. At this point, I don't even have to make an endless runner. We can just have it as a cool little Mega Man game. Once Andrew makes the bosses, we're gonna be in business. We're gonna make a little random boss generator thing, so when you get to an end level, it just makes you a boss. What we could probably do that's more in line with how the original Mario Brothers worked is that you won't be able to go backwards. But technically, I have like enough now where I could probably just where I probably could just build out random levels. They'd be horizontal for right now, just the way that I'm doing this stuff. But I can come up with something pretty interesting. Sorry if you hear me drinking. Let's do this. Let's test. Let's test if this thing is actually like not just completely awesome for the player. And let's add physics to another entity. And then we'll get the real test. So here's what I'm gonna do. I'm gonna spawn this hardhead guy. So he's just gonna move forward, right? And what we're gonna do is let's get him to work with the physics engine. So the first thing I want to do is we got to add some collision to that dude. All right, let's get rid of this and get rid of this. We don't need this anymore. Our physics engine should be good. Every time I fucking say that, something breaks. I just want to delete all the code that we're not using. And I need to make a need to calculate the correct position to shift back to avoid sticking to walls. All right, that works. All right, let's add our guide here. So now what we need to do to our entity is configure player. What we do for the configure the player is the first thing we want to do is make sure that his collision stuff is set correctly. So we will come here to the hardhead guy, configure collision, which we've already done. And on update, we are going to debug his collision box. So this is the first step, right? As he walks, we're going to see his collision box isn't that bad. I don't think I'm going to change it. It's not worth it for right now. Now what we need to do is add in update physics on the entity. And remove his move code. So now he should just fall to the ground or break. What the fuck just happened? Physics line 50. Oh, I never configured him. I gotta configure him. It's hard not to sing while I code. I have like music really loud in my headphones. I don't know why. Could you please explain how it works internally? What you're developing? How does it work internally? How about this? Could you be a little more specific? Because there's a lot of shit going on. You want to know about how Pixel Vision 8 works? You want to know how this game works? What part of this game works? Happy to answer any question you have, as long as we can agree on what I'm answering. All right, let's configure the physics. And our dude is... Where the hell did our dude go? Oh, there he is. All right, so as you can see, he's now deleted. All right, I was trying to figure out why his rect was showing up there, and that's because he okay, I need to do something to fix that. That's just a bug on the player's collision rect only shows up when you are on screen. I'll deal with that in a minute. All right, so right now he's stuck in the floor. All we need to do is give him, so just like the player, when we press forward on the player, we simply give him a velocity. I'm trying to find, oh no, he automatically has a velocity. No, he does, all right. Let's see, we're gonna give him a velocity. Hardhead, walk, on update. On update, we're just going to keep updating his velocity and setting his velocity to -1. There you go. And look, he hits that wall, and he now is part of the awesome collision system. All right. So next, what I want to do is get him to jump. So what we're going to do is a entity jump time equals 0. Entity jump delay equals 1 equals, yeah, we'll do it 1 second for right now. Entity and do that. All right. So now what we're going to do is entity jump time is going to equal entity dot jump time plus time delta, right? And then next we're going to see if, whoops, I need to fix this. If entity jump time is greater than entity dot jump delay, then end. And now we need to do the last thing is now if entity dot standing equals true, we're going to apply a vertical velocity to it. So what do I do? -5 here? Let's set it to like 3 or something. So velocity -5, and we're going to reset the jump time. So now what's happening is that we're going to keep a timer to see when he should jump. When he hits that timer, if he's standing, he will jump again. And we're going to play with the delay versus his fall time to see how that works out. So he should hit here and then throw an error. I meant to do that. I can't spell, so that's like 100% of my problems. Almost 100% of my bugs. Look at that. Look at that! Holy shit, that's awesome. That's really cool. He jumped over the obstacles. So like, okay, that's like basic AI right there, right? That's like stupid basic AI. The next we could do is we could say, hey, look ahead of yourself, and if you see that wall, jump over it. You know, so let's go play the game, man. Let's go kill some stuff. Jump and shoot, man. Look at him jumping. All right. That's cool. It's like, it's really cool when it like works. So the other thing is that you might be like asking like, okay, well, why don't you, you know, why don't you put all the other stuff on physics? Like, why don't we do physics for the bullets and physics that all this sort of physics stuff for the snake? And the problem really is we don't want to have all these. We don't want to be doing all this calculation during each frame. Like, you got to imagine the Nintendo was a pretty basic system, right? So now what we're doing is we're only testing stuff that we know needs to be tested. And in fact, we could do some cool stuff with like the snake, where if the snake sees that there's a gap or something, it would just turn around. And I might add all that stuff in. I mean, it looks like I've taken something that's become like a simple game and turning this into like a really proper thing. Let's see here. Yeah, how does C# and Lua work together? That is the basics of the game engine. I use a library called Moonsharp, and what Moonsharp does is Moonsharp is a C# VM for Lua, and it exposes the Lua VM. It exposes the C# hooks to it. So I basically have a game class, and then I have a Lua game class. And the Lua game class, whenever you call a method on the Lua game class, it calls the Lua methods underneath. And to sort of give you an example, like in this, you're basically going to see, there's always going to be a performance hit for something like this. So like if I go here to sprite draw demo, for example, I mean, it's running pretty close. Like every now and then you see it'll dip some frames. It's running at about like 60 frames a second. So it's not bad, but where you really see the performance hit is on something like this. Where's this spirally spiral demo? This thing, it's running at about 19 frames a second. Granted, Pixel Vision 8 was never designed to do this kind of stuff. I just really like these tweet carts that people are creating. And the block right now is there's a very tight for loop that generates out this artwork. So you get like a huge performance hit. Now, if you did the C# version of this demo, 60 frames doesn't even like bat an eye. So that's sort of the difference you get between using it. But everything else runs pretty fast. I don't know if I have any other like really like complex demos. Like this is the other like more complicated demo, but it's running like this one's doing multiple background passes. It's changing out it's palette swapping for the water. And it's still running at about 59 frames a second even. That other counter where the gems are is counting how many sprites are on the screen. So that's sort of at a long story short how this all works. But all right, I'm pretty happy with this. One thing I want to do with this debug collision is when we debug the collision, calculate rect debug collision. Scroll position. If use scroll position is true, we'll use this, or false. This will fix, or basically what we're doing is not everything needs to offset by the scroll position when it's drawing the oh no, it did need that. I guess what I just need to do here is come up with a better way for need to make sure we only draw when on the screen. All right, like the debug stuff I could really give two shits less about. That's more like if it shows up on the side, like that's just testing stuff, right? What it's really more important for is like right here. Like let's go and now that we have this guy set, let's tighten up his oh look, he's jumping. How cool is that? He's just, because now he can't move, he's just jumping. If we came in and we fixed his configure the collision area, what we'd want to do is set it to we're gonna make it 16. It should be 16 by 16. And we'll make this 0, 0 plus 1. And we'll just offset it by a little bit. In fact, let me get his height 15 and see if this lets him land on the ground a little bit better. There we go. So now you get his collision wreck and stuff. Yeah, and I created the Game Creator Pro. I created everything. This whole thing is built literally from scratch. The only thing that I didn't build is that I use a single quad texture to render in Unity to display everything. So this was actually compiled with Unity. It doesn't have to be compiled with Unity. I'm planning on moving it over to Mono. I can't stand Unity anymore. But yeah, I built this whole thing, the game engine, the tooling, everything. 2.5 years and counting. All right. So cool. So now he's hitting the floor correctly. Let's do this. Let's get rid of his debug code. And I'm going to stop. I think I'm going to stop my stream for the day and then go grab some food or make. I got to cook myself some food. I got a lot of food to cook before I leave on my trip. I can jump too. There we go. Going and killing stuff. Like the American way. There we go. All right. Jump and Shoot Man is actually a game again. What we might want to do is we could get it to where we could do some stuff where, well, I need to change the physics so that when he walks, he accumulates inertia or accumulates velocity at least. That's really what's missing because now he's going too slow. And that was cool. That's going to be a problem. He now hits that ceiling, and he can't do these jumps. So I'm gonna have to redesign a little bit of this because he jumps higher. He jumps a little bit higher. Now I wonder if his speed was a little bit. Let's test something real quick. Let's go back to the player. Let's lower his jumping to like 3, but increase his velocity to 2. And I just want to see if he... No, he needs a... That feels like a good jump. Yeah. Oh, perfect. That's what it is. The speed isn't fast enough, right? And having that speed is what gives us that inertia to make it past the jump. All right, cool. Wow, I'm so happy with the physics. Like, they came out really good. It's like, this is going to be an awesome little tutorial. Moving as fast as my bullets are. It's like no gravity. There we go. All right, so the only thing I need to fix really, and I don't know, we'll see how I want to do that, is it's just, we gotta see how fast we can make him run. Because like him like immediately like going to full speed is just like boring. What it should be is that he accumulates that speed, that he ramps up to that speed, and then, hey, Mohammed, welcome. All right, I gotta get off. I gotta go do this call. So work calls. All right, thanks everyone for watching. I think we had a super productive morning. I'm gonna be gone for the rest of the week. When I return. One of two things will happen. Either all the bugs will be fixed for this next release of Pixel Vision 8, or I'll have Jump and Shoot Man done. And then what I want to get done is I want to turn this guy into a tutorial. That I'm probably not going to stream. I don't think anyone really wants to watch me write. Maybe. I don't know. What do I know? And then I'm just going to release bits and pieces of this tutorial and just talk about game development. It's cool. All right, thanks everyone for watching. Again, I'm quitting out of all this stuff, and I'll be back next week. Sounds like a long time, but it'll go by really quickly, I promise.